Quadratic functions in factored form, investigating difference of squares binomials. We're going to take a look at a couple binomial products and we're going to expand them, and we're going to remember that when we see something like this, we're really using the distributive property. So we're going to take the x and multiply with the x, and multiply the x with the 2, and then the negative 2 with the x, and the negative 2 with the 2. So if we want to write that out a little bit, we can just write it as two separate products, x with the x plus 2 that we saw up with the top arrows, and the negative 2 with the x plus 2, which we saw in the bottom arrows. So when we distribute x times x, it's x squared. X times 2 is 2x. Minus 2 times x is minus 2x, and negative 2 times positive 2 is negative 4. And we have to group together our like terms, and we see here that our like terms are opposite, and we end up with x squared minus 4. If we look at this one here, negative x plus 3, we're going to do the same thing. The x gets multiplied with x, and the x gets multiplied with the plus 3. So we see that right here. And then we multiply the 3 with the x and the 3 with the other 3, which is what we see occurring here with this bracket. And when we do that, we get negative x squared, subtract 3x plus 9. And again, we see our middle term goes away, and we're left with negative x squared plus 9. X plus 5, x minus 5. Again, the same process. We need to distribute x times x minus 5 and the 5 times x minus 5. We're left with x squared minus 5x plus 5x, subtract 25. Now, often, when we expand and simplify to binomials, the result is a trinomial. And why didn't that happen? Why did we get a binomial each time? What was common in all of these questions? If I look at these, what do I see in terms of the number portion? If I look here, oh, wait, that wasn't the same in the number part. But here, I ended up with opposites. Here I had the same number, and here I had the same number. So the opposite numbers. So the numbers don't always have to be opposite. But here the numbers were opposite, and the variables were the same. Here the numbers are the same, but the variables are opposite. And if I go back here, the numbers were opposite, the variables were the same. Is there a pattern? As long as one of them, the first term, I've actually written this incorrectly because I changed my questions after. So one term in each binomial was the same, and the other term were opposite. And that was the big key. So when we expanded the product using the distributive property, the two middle terms were always opposite, and we became 0, and we were left with two terms. The significance of that, the two terms that are left, let's go back and take a look. X squared, negative 25. Negative x squared, positive 9. X squared, negative 4. What do we notice about them? Well, this is a positive, that's a negative, a positive, a negative. So if I think about it, one term is always positive, the other is a negative. Let's look at the numbers themselves. 25 is a special number. 9 is a special kind of number. And 4 is also a special kind of number. They're what are called perfect squares. And I can take the square root of, if I forget the sign here, I can take the square root of 4. And I can take the square root of 9. And I can take the square root of 25. So if I'm just looking at the number part, they're all perfect squares. If I just look at the number part of the variable, I can take the square root of x squared. I can take the square root of this x squared. And I can take the square root of this x squared. Well, that's all great. But the bigger thing I want to figure out here now is how can I take what I'm left with, this part here, which is called a difference of squares binomial, and make it go backwards. And that's what we need to think about for tomorrow's class. Okay. If I look at these were all difference of squares binomials. So I have something squared, and I'm just going to use a heart for the sake of it, a shape, subtract something else squared. I could also have written that as negative something squared plus something squared. The key is with a difference of squares binomial that I've got one positive perfect square and one negative perfect square. So that's the important piece when we're trying to identify them. So for tomorrow's class, I would like you to try and complete exercise 4, pages 6 to 9, questions 3, 8, 9, 15, and 16. And I will see you tomorrow.